See, look at this problem. Point charges q and minus q are located at vertices of a square with diagonals 2l as shown in the figure. Find magnitude of the field, the electric field strength at a point located symmetrically with respect to its vertices at a distance x from the center. That means the point where you have to find the field lies here. It lies there on this perpendicular to the plane of the square through its center and at a distance x from it. Let me draw the 3D diagram of it, then it will be more clear. See, so if you make a plane, right, that's a plane, right, and these are the charges. Right, these are the point charges, plus q, minus q, plus q, and again minus q, and through this center perpendicular to the plane on this line, perpendicular line, you have a point P and the distance of the point P is x. There it is, distance of the point P is x, and you need to find the electric field at this point due to the charges. Now, as you know, we are free to choose the axis as according to our will. So we'll choose the coordinate axis. Okay, so for convenience, generally the plane we choose as the xy plane, right? Now suppose this is the x axis and they are maintaining the right hand coordinate system. This is the y axis and this will be the z axis. Okay, so the coordinate of the point P, what is the coordinate of the point P then with respect to this coordinate system? It's x coordinate 0, y coordinate 0 and z coordinate x. Z coordinate x, okay, doesn't matter, the z coordinate is here x. Okay, and the coordinates of these charges, see this distance is L, right? So coordinate of this charge is x coordinate L, x coordinate L, okay, y coordinate 0 and z coordinate 0, and this is having x coordinate how much, 0. See x coordinate, if you have problem then you can construct the axis here also. See, this is the x axis and this is the y axis, and above you have the z axis. So from here it is more convenient. So that's this charge, right, minus q is this. So x coordinate 0, y coordinate minus L and z coordinate 0, and this minus q is this. So that is having x coordinate how much, it's having x coordinate minus L and 0 0, and this plus q is this one, right, this charge is this one. This is having x coordinate 0, y coordinate L and z coordinate 0. Now we will apply Coulomb's law in vector form. So we will apply Coulomb's law in vector form. So in vector form, Coulomb's law is like this, na? See, if you have to find the field at point P due to the charge, due to a certain charge, say Q, so that's at point P, vector form of Coulomb's law is this, kq by r cube multiplied by r vector. This is the vector form of Coulomb's law. Now for this problem, the field at this point P due to this charge, let us find out this. So the There were 4 terms, right? E equal to, now I will write k here at last. In the last step I will substitute k as 1 by 4 by epsilon naught. So that's k into q by this r cube. Now what is this distance? This distance is uh, this, each of these distances root over of L square plus x square, right? So that becomes a cube, so L square plus x square to the power 3 by 2. Now what about this vector? What about this vector r? This vector r is, you know, that difference between the coordinates, so it's 0 minus L, so minus L times I cap. Now 0 minus 0, so nothing in y cap, and in j cap you have x plus x minus 0 k cap, sorry, L I cap plus k. Okay, so the other terms also you can find k minus q by, again this will be the same, L square plus x square to the power 3 by 2. I mean it's for this charge. Now let's write the vector joining this point to this point, subtract the coordinates 0 minus 0. So 0 into I plus 0 minus minus L, so L j cap, acha, plus x k cap. So in this way you have to write two more terms for this charge and this charge, and you get a vector form of the field, and so you can calculate the magnitude. Okay, so you can do it yourself. I have just shown you the way of doing it.